we compare, right? 400, 450, and 480. These are the possible IS that we can select, the setting current. So we select, if the fault current, we select the highest fault current to consider. The setting current, we also consider the highest setting current that we can consider, which is 480 amp, right? So we select 480 amp. So now remember, we are still at bus C, right? We are still at bus C, right? We are still trying to do the setting for relay 1 and relay 2. So if, let's say, in this example, I'm using the inverse, the extreme inverse curve. You can use any curve that you want, the standard inverse curve, the exponential inverse curve, whatever curve. But let's just say that we use the extreme inverse curve. The difference between all those possible curves are that different curve will give you different reaction time. The reaction time is given to you by T. The TMS is the time multiplied your setting, and the IR here is the relative current between your fault current and your IS, I setting, right? So this is the equation, the simple equations for the extreme inverse curve, and we are still at bus C. So possible setting for relay 1 and relay 2. The TMS, this is the first one, right? 0.3 plus 0.05. Why 0.05? Because fuse number 2 has reaction time of 0.05, and why plus 0.3? Because the standard is that between protection system, right? In order to ensure grading, the standard that has been accepted is that protection system, the grading between protection system, the grading, in other words, is that the reaction time between two protection system should be at least 0.3 seconds apart. So the technical term is called grading. So the grading between protection systems, the time grading between two protection systems should be at least 0.3 seconds apart. So the first possible one is to grade with fuse number 2, which has 0.05 seconds of reaction time. So 0.3 plus 0.05 equals to TMS multiply AT. This AT is the fixed constant of the equation. IR squared minus 1. IR squared, so IR is the relative current of the fault with the setting current. So the fault is 9.33K that we considered, and the setting current is 480. So we substitute all this value inside, and then we get TMS of 1.65 seconds. And this 1.65 seconds is the TMS of the relay 1 and relay 2. All right. So the second possible setting is that to grade against, just now we grade against fuse 2, now we grade against fuse 1, which has 0.02 seconds of reaction time. So again, to ensure grading protection system reaction time between two should be at least 0.3 seconds apart. So we add 0.3 equals to TMS multiply 80 divided by the IR, R squared minus 1. So the IR is 9.33K divided by I setting. So, and then you get two possible TMS. TMS 1.65 seconds and 1.50 seconds. So just now, when we select the IS, we select the highest possible IS, 480 seconds. So now with TMS as well, we also select the highest possible TMS, which is 1.65 seconds. So therefore, to ensure grading, relay 1 and relay 2 should have TMS setting of 1.65 second and IS of 480 seconds. Okay, why these informations are so important, all right? The final two important informations that the relay need in order to perform their protections. In order to understand this, then we look at the inverse curve, okay, of this extreme inverse curve equation. Because when you look at this extreme inverse curve equation, when you have a particular fault striking bus C, so let's say the fault is IF, right? And then we know what is the TMS and what is the IS. Then this equation can be substituted completely. So we have TMS already from here, and then we have the IS already, I setting for the 80 amp, and then the fault current entering. We also can put inside IR here. From here, TMS and IR, we have a complete information to determine what is the reaction time of the relay 1 and relay 2. It could be 0.01 second later. If let's say a particular fault strike, then relay 1 and relay 2 will trigger the protection system to trip feeder 1 and feeder 2 when you have a particular fault happen at bus C. So therefore, TMS and IS are the two most important informations that any relay needs to perform to determine their reaction time when a particular fault happens. Okay. So just now we look at bus C, right? So the grading at bus C is the same as the grading at any other buses. So now we look at the grading at bus P.